So very quickly, just quick intro. My name is Dennis Chu. I'm the Director of Product Marketing here at LightStep. And I'm going to walk through just a quick demo walkthrough, typical workflow that some of our customers might go through to use our products to diagnose problems, to monitor their systems. Before I get started with the demo, I just want to put this slide on the screen very quickly. Spoons will talk about this in much more detail, but basically our satellite architecture has two parts. They have the satellites themselves, which run within our customer's own environment, VPC, data center. They're the ones that are ingesting all of this data that a typical microservices heavy architecture or any distributed systems really will generate. They're part of what makes it possible for us to analyze 100% of our customers' data. This can be quite literally hundreds of millions of calls and requests per day. But if we were to send all of that information to our SaaS, that would just be crazy. Your AWS bill would be through the roof. So they're really the ones that are doing a lot of the heavy lifting, computing the statistics that then gets sent back to our SaaS to do a lot of the to generate a lot of the insights, to separate out the signal from the noise, and then give our users the assistance they need to really understand the performance of their software. So that's a very high-level description of the architecture, but I think it's important to keep this in mind in the context of the demo. And again, when you have some questions, Spoons will be happy to go through this in much more detail. So with that, I'm going to switch over to my demo. I hope this is clear, but I also wanted to just set the context of a distributed trace. For some, this is a new concept. Others may be very familiar with it, but this is not something that is unique to LightStep, but I think it's a very important part of what we do, is to present this type of trace information to our users to help them understand exactly what's going on. Now, each of these colored bars here, they represent a different service or timed operation. And the way we present these traces, as do some other tools out there, it adds the context of timing, and it also adds hierarchy. And that's very important to know in these distributed systems, what the order of things are going on, so that you can actually figure out if things are happening in parallel, serially, things that to help you tell that full story. With that said, a trace is not a magic bullet, right? Because again, you might have hundreds of millions of calls, so you really need the right trace at the right time for the specific problem that you're solving in order for you to actually know what's going on. Otherwise you're just like looking at these many times and then trying to correlate them. Again, that's not really very helpful. So, how is LightStep different? Before I jump into what a typical user workflow might be, I also want to show you that this is really what's very different about LightStep XPM, is this latency histogram combined with the architecture. And really the architecture is what powers this. So we present an entire distributed systems performance in this histogram. And this is why we really like to talk about performance as a shape. Because when you present performance in this histogram, now you can see the very unique and distinct behavior patterns, because the histogram clusters these unique behaviors that if you're just measuring, and actually by the way, this is a brand new feature that we just enabled quite literally yesterday afternoon, where we just track also the latency percentile. So everything, right now I have it set to P95. So everything to the left of this marker is basically the 95% of all the transactions are to the left, and then 5% are to the right. So, but if you're just tracking it by this fixed percentile marker, then you're not really seeing kind of all the different independent behaviors that are occurring in this very complex system. This histogram, because of our architecture, again, it's analyzing everything that's going on in your application, and you get this very rapid feedback. Now I'm just isolating it by the iOS client service, and you see this histogram completely changed. The shape looks completely different. So when you're looking at everything, the P95, if you notice the marker, it didn't really change a whole lot in where it was. So now you can really, like what Ben was saying, very rapidly test your hypotheses, use your intuition to understand what might be slow, and then very rapidly kind of iterate and validate your correct hypotheses, but also just as importantly, reject ones that are incorrect, so that you can really narrow down to what the root cause is.
That process is still manual, right? So I think finding root causes, getting up with thinking of an hypothesis and then testing it is still a manual process.
Yes, but I'll show you how we automate some of this. Mm-hmm. Unfortunately, there's no magic, like if your system is slow, there's no magic bullet. It's like, change this line of code because this is what.
Does it learn from it?
Does it learn from it? So we have some things in progress that's really trying to analyze the situation more. I don't want to call it like full-blown machine learning. I feel like the whole machine learning AI thing is a bit overdone. But we're really doing a lot of very sophisticated computation in the background to really help and guide our users to that.
So you do basically normalization, and you look at previous data to see changes or to see.
So that's a great question. And one thing that we also have is, if you look at the top right here, we have this compare to. We call this the historical layer. It basically allows you to see what this shape looked like an hour ago, a day ago, and a week ago. We feel like this range lets you see things that degraded very rapidly, but also the week length gives you like enough time to see if there's like some systemic problem that is taking longer to manifest versus some like immediate failure.
It just wanted to check here. That might be coming up, I don't know, in the next presentation or something, but would it be useful to actually have a few words about how do we actually get to this state, i.e., how does the monitoring, so I'm assuming that there's statistical modeling going on behind that, but how long do you have to run this environment for, so that how do you get this data in the first place, or historic data, so that what the setup process is, so that people can understand this is where you get to first, and then you start getting these results. So I think it would be useful if that explanation.
So I'll briefly answer this, but I think Spoons will probably go into it in more detail. One of the great things about our architecture is all this happens basically immediately. Our satellites are designed to capture and show you not just your real-time performance, but it also on the background captures this historical information, and it's basically saved in our SAS. So this information, again, there's no limitation to the tag cardinality, so you can be very focused. Now I'm just showing you this giant iOS client service, but I can filter by like a specific customer ID. And if you imagine some of our customers, they might have tens of thousands of customers. So you can really see the performance for an individual customer right now, but also along these historical, basically, time facets.
The reason why I asked that question, just to sort of explain, is that traditionally monitoring systems, especially the traditional ones, actually start from a process of getting the system in. It monitors an environment for a while, say, I don't know, a month or something, and then based on their own modeling, they come up with some sort of, I don't know, baseline, and then say, okay, whatever is now an anomaly, you capture that and alert on that.
The approach is very different with this than the traditional model of doing these things. I think we've struggled a bit with categories, frankly, because you can say APM, and I think if you think about APM as being application performance management. Like, you want to manage your performance. Yeah, totally. Like, that's what we do. But the way that APM traditionally does that is completely different than what we're doing. There's no, aside from the aspect of working with our customer success team to literally just ingest the data in whatever format you have it, as long as we can latch onto some kind of correlation ID that will stitch a transaction together across service boundaries, that's it. You need to wait an hour for the hourly data to be available, but that's just, from becoming a customer. But there's no configuration needed here. And I think I would want to kind of underline what Dennis just did here. The fact that customer ID, this is a big deal. Some of our customers, as you said, tens of thousands, it's more like millions. They have millions of customers, but the top 100 of those customers generate 75% of their revenue. So for them to be able to focus on individual high-paying customers is profoundly important to them. Ironically, those top 100 customers have the worst performance, as they have the largest data, and performance is data dependent. So this pattern repeats with basically every SaaS company we talk with as a prospect. Their biggest customers have the worst performance, and they need to focus in on that. But being able to do this kind of thing where you can slice the data at this kind of granularity is not really possible. And the little drop line around P95 is all you get from a traditional time series system. Actually, you're excited these days if you get P95 or P99 instead of average latency, which is truly meaningless. But being able to track a specific percentile, I think, is actually not that great in terms of understanding the behavior of the system and having hypotheses to test. All it tells you is that something is broken. It really doesn't help you isolate the different behaviors or understand the nature of the system. And yeah, this is looking at an individual transaction now. That we can isolate. And that autocomplete goes all the way through the satellites, by the way. So the satellites are not like a store and forward collector, as Dennis was saying. The UI that you're using here is making a full round trip into and out of the satellites. It's more like co-located storage and compute. It's a very different model. And I think Spoon's presentation will illuminate a lot of the mechanisms that we're using for this, but it's hard to compare it to a traditional monitoring system, I think, because it's just a different way of building it. So
how about the tags you're entering now? Can you create custom tags where you filter a specific version of your app?
Yeah, that's exactly, yeah.
So that what I just showed you was like, I'll just do it again. It might even be a different one now. So we have these tags that literally just charge IDs. That the demo environment basically simulates like an e-commerce site that's doing a lot of credit card processing. So you can literally pass in every single unique charge ID. We'll find that single trace that represents this one. And then as you see on the bottom, we'll actually show you the example so that you go directly to that trace, to that operation. And then you can walk up the trace to, I guess, the top calling one. Look at the payload, look at the CCV hash, the user ID, the date it was, the date stamp. And then these, you can also include tags for the client version, the specific customer, the version of iOS. And this, like Ben was saying, you can really have a number of use cases. You can look at your different client versions. You can do canary testing of all your different builds. You can track your different product versions, beta customers.
Can you pivot over to the live view for the iOS version just to make from the tag? Unfortunately, the screen here is literally there's some sort of zoom on the TV, but there's an icon there to pivot over to this view. So this is, per your question, this is a view of performance for every piece of data from this version of the iOS app. And
do you have to enter these tags beforehand, or are those dynamic?
Typically things like this that are per instance is part of the way the SDK is configured. You can pass in tags that will apply to everything coming from that process. Right. And so that's how it's typically done. And then we'll grab other things from, if we can get like Git SHAs and stuff, we'll grab that automatically.
Yeah, exactly. And one more question about the compare to, right? So it's now a day, a week, and an hour. Is that customizable, or will that be customizable? Because different companies have different periods that matter to them, right? So I work for an e-commerce platform where the year-over-year comparison is very important. So I'm missing the 1 year ago, basically. My use case.
The underlying data here is our main challenge is finding the right way to visualize it. It's much much richer than this. So that wouldn't be difficult to build. I don't want to put a date on it just because it's not part of our...
But there is no inherent limitation to the amount of the amount of data you store?
Correct.
Right, okay.
So it's a UI, UX problem. I don't want to trivialize it. I mean, it's a real one because there's a lot of data, but that's the issue. I think talking with customers, this is the sort of, when they're trying to firefight, these are the sorts of things they want to know. Because it's like if they're getting woken up at 3 a.m, the year over year is not that interesting. Like they want to know, was this actually happening an hour ago?
Yeah. So one of the limitations I run into quite a lot with different products is I do want to compare it to a month ago or a year ago.
Yeah.
Even at 3 a.m. just to refresh my memory. Okay, what was the normal behavior again?
Yeah.
And then we run into limitations where the traces of a year ago aren't stored anymore in that granular format. It becomes an average or a summary or something not as granular.
That's yes, definitely. The general philosophy we have. Sorry, Dennis. If a human being sees it, it's stored forever. So like all those traces there are assembled retroactively. It's another thing that we'll talk about a bunch today, but tracing systems generate way too much data to store all of it centrally. That's just a fact. And we aren't able to solve that. It's this fundamental law of nature kind of thing. But the fact that we can store traces retroactively is massively, massively important to understand, in that rather than sampling this randomly or based on a heuristic, it's that the user cared about these traces. We have a window in the satellites to collect them and store them forever. So all of those traces are links that will be there forever, and there's no timing out or averaging or aggregation of that data, which is...
That's because you store it not on an on-prem satellite, but in your SaaS server.
Well, yeah, exactly, and exactly. So all the durable storage is in the SaaS. Exactly.
Makes sense.
Yeah, and we'll talk more about that.
Yeah.
Yeah, and I also want to go through what, as far as I know today, there still isn't a customer with LightStep in their title. So they have day jobs doing like software engineering. So just spending the whole day in LightStep is probably not what they're doing day to day. So we do still build out all the typical, monitoring, performance management, bells and whistles types of features, including dashboards, as a way for that quick feedback of, is there something that I should go into LightStep and really dig into more? So as you can see, you can kind of zoom in on specific time ranges. If you see the spike, you can drill into the time series view to see this very rich, more granular view of this particular service. And again, there's no limitations on how fine-grained these charts can be. You can, again, monitor specific customer, specific build, specific transaction ID. That won't be very interesting. You'll just have a single dot, but it's possible. Once again, while we're not storing every single trace, you can tell by all these green dots we're storing quite a few, typically far more than you really need from like just the things that you would want to see, but definitely like a good sampling of all the types of information that you need for all the different interesting events, all the way to these like truly anomalous I think this one, what is this, P99.98. And if you think about a lot of approaches that might do upfront sampling, they're tossing out 90% of the transactions, your P99 might actually be very different. Like what you see might actually be very different than what it actually is. We can, to just like make it easier, I can just like filter out the information, so I can just focus on the truly outliers and anomalous ones.
Okay, can we just focus on the fact that you just on the fly edited the data set that you're looking at? That's pretty awesome.
Yeah, so most vendors have stored percentiles in their as a time series in Cassandra, whatever they're using their backend, and we don't do that. So every time slice we have a full histogram, which allows us to compute. I mean, why don't you change it to P99.97? I mean, it doesn't matter. So we can compute percentiles on the fly, which is actually something that we should probably spend more time talking about, because you're right, it is something that's difficult to do and really useful. And Dennis, I think, sort of brushed over this. I want to make sure people understand the idea of seeing a time series of percentile data is not that interesting. Being able to choose the percentile is interesting, but what's particularly important is that these green dots are transactions that like those full traces that we saw earlier that are at those different percentiles. And the fact that you said solutions throw out 90%, Dapper at Google threw out 99.99% of the data. So if there's an anomalous transaction, you almost always threw it out if you're doing conventional sampling. The fact that we can go back in time means we have the benefit of hindsight to contextualize what's slow and what's fast. Ironically, you don't know if a transaction's slow until it's over. So if you do the sampling beforehand, you can't do this. So it seems kind of obvious, like, oh, of course you'd want to sample the outliers, but I want to underline you cannot do that unless you're sampling after the fact. And to the best of our knowledge, no one else is able to do this. So this is a huge thing, because the outliers are the ones you care about, but they're the ones that get thrown out. So that's important to underline too.
Yeah, and then of course, once you find that, you can jump to that trace. And again, it's about finding the trace that you care about when you care about it. And this now you can walk up and down. It's starting at the iOS client, so really from the mobile client all the way down to the lowest this database call. And you can even see, interestingly enough, here you can actually even see how the database is the different queries for the database, these select filters. So if you think about it, some of our customers, they look at it and they're like, oh, all my database queries are happening serially when they can happen in parallel. So there's we've actually helped some of our customers, in essence, understand how their software is running, where they can build optimizations. Yes.
Yeah, so this is a lot of information that some companies might deem as sensitive. And you've said that you can't process it or store it all locally. So are you working on like a government cloud or some sort of secure version of this for other customers?
Yeah, so our satellites, because the satellites run in our customers' own environment, they can actually customize it to scrub like personally identifiable information. So for like financial institutions, if they have to do their or like healthcare companies with HIPAA compliance, they can actually scrub specific usernames or social security numbers, but still retain they can even turn it into something that is less sensitive, that's not personally identifiable.
Well, I might be able to scrub the PII, but I still have full queries that are being run.
So I think it's a good question. There are definitely prospects that we've spoken with who just literally will not buy SaaS. And we try to get that question out of the way pretty early. For the people who are willing to buy SaaS, we've never not gotten through a security review. And a number of our customers that are referenceable logo customers are big public companies that take this stuff super seriously. And so do we. So I don't want to trivialize the question. I think it's totally valid. There are business metrics you can infer from LightStep data, even if, let's throw PII aside for a moment. Just knowing how many rides a day Lyft is doing is a trade secret for them, So there are things like that we take that incredibly seriously, and we align ourselves with the industry best practice around security, which I think is enough of an assurance for the security teams we've worked with after they've audited what we're doing here to feel comfortable. But it is definitely a concern, and there are some businesses that there's some kind of race condition here between customers being willing to buy SaaS and us willing to sell on-prem. At some point, one of us is going to blink, I guess, but so far we haven't had too much of an issue with it when people actually audit what we're doing. So.
What about federal government customers?
It's really the same answer. I mean, I think there's some economic driver here that is an important component of the conversation, and I don't want to make a firm statement about what it would take for us to build a separate version of LightStep, but it could be done if we wanted to. It's not like a profoundly difficult thing. It's just velocity for us is really important, and I think for our customers, they benefit from us releasing product quickly, and that's what I'm optimizing for when I think about this at the moment.
So do you run your own tools and services against LightStep as a service, like
Yeah.
on your own?
Yeah, we do. Yeah, and I mean, well, in the past we often gave demos of our Meta service. We called it. It's a separate instance of LightStep, just to, for all the usual reasons. And in some ways, the data is really compelling. Like the histograms look more real to me as someone who's looked at these a lot than the demo data, and they're very bumpy and interesting. But then you get to these, all of our code names internally are named after salad ingredients, and people don't understand why is this crouton talking to salad bowl and stuff like that. So we've decided to use a demo app with more normal service names like database and cache and things like that.
Right.
So, yeah.
Just quickly going through the typical, workflow that some customers, they might go to this trace, they'll see, oh, it's affecting that customer that we really care about. Now they can go back to it. Once again, they can use their intuition to think, oh, maybe the payment gateway, it's third party, something's happening there. I won't go into this too much because we already talked about it. But again, if you look at some of this historical data, it can very quickly answer the question, well, is this normal behavior? Has something changed? When something changed, when did it change? And just from looking at this now, you can clearly see that while your transaction volume might not have been different, everything has, for some reason, shifted, giving you some insight. You can even filter to narrow down to just the slowest parts so that you can go in and dive deeper. Also, when you create these dashboards, we have the ability, again, this is not necessarily unique, but I think very important for many of our customers to be able to create alerts so that they can get notified when they've exceeded some SLA. Because we can do these very fine-grained, like monitor and track the performance of these specific customers, we literally help our customers maintain their SLAs and their SLOs with their top priority customers.
I think that's important that you mentioned that you also have alerts, because one of the things I noticed on your website was that you talk about monitoring and comparison and isolating problems and anomalies, but it doesn't mention the word alerts, and that's why you do alerts, right?
Yeah, and this is something that we've been told anecdotally that the alerts we deliver arrive within a couple of seconds of the problem occurring, and when we deliver the alert via Slack or PagerDuty or OpsGenie or whatever, it'll include links to transactions that violate your conditions. So that's a huge improvement. If you're woken up in the middle of the night, one option is your service is slow. Okay, shoot, I'll open my dashboard, my logs, et cetera. The other option is your service is slow. Here are links to 5 traces from the last 10 seconds that illustrate that slowness and help you understand in the system where it comes from. And that's a huge, huge thing for our customers. And the Twilio case study was very real. They internally measured a 92% improvement in time to resolution for real-time alert response using LightStep, and that's why, is that the alerting flow is, I think, profoundly better if you can jump directly to trace.
I think you should definitely make it a bit worded so that people understand that it's not just monitoring or comparison, but also you get alerts very quickly, and then you can immediately see what's wrong.
Yeah,
right.
That would be useful, I think.
Good feedback.
And I just created this 11 a.m., which actually tells me I'm almost out of time. But as you can see, these alerts, just as this one simple one, you can go to the live view for this particular violation, but we also show you these very specific example traces, so you can just, if you don't want to even go to the histogram to see that component or that service, just jump straight to a specific trace that is violating your SLA. Then you can know exactly what needs remedying.
Yeah, and this trace is still assembling on the top. We allow, it's kind of, you never know when something's done until nothing's showing up anymore. So this trace is, we'll send things that are mid-assembly, and they'll be assembling in front of your eyes during the alert response, which is pretty cool.
Yeah, and just the last thing I'll say is, and I won't demo it because it's not particularly interesting to demo, but we do have enterprise features like role-based access control, where there's people who can create these alerts and administer the account versus people who can just view. So if you just want to have like a contractor be able to view but not really mess with your dashboards. That's supported. Things like single sign-on. So as Ben was saying, this trace is now mostly assembled, but we also have those types of enterprise level features as well.
Last thing I'll mention that also doesn't demo well, but it's really important because it came up earlier, I think, implicitly when you were asking a question about different data fidelities and time heuristics and so on. Basically, everything in the product is either already driven by an API or we intend to build that soon. And I think our philosophy is not to generate one ring to rule them all. And it's like, yeah, you use LightStep, but you have to throw everything else. Like we just try to integrate with people's workflow, and that's usually done through for public APIs that we support. And so everything here is intended to be API driven as easily as anything else, and all these things embed in Grafana and so on and so forth.
Yeah.
So that's an important
so
part of our
that was the follow-up question. So that means it's pretty easy to visualize this data.
Yeah, absolutely.
Inside of Grafana.
Yeah, we consider the data to be, frankly, very difficult to gather and it's quite differentiated as data. So we're pretty, we play nice with others on that stuff.
Yeah, we have integration with Grafana. We have an URL. You can embed this as this view as an iframe, so you can build your own custom dashboards.